Okay, first, welcome back to the channel of ATAR Maths Exam preparation. We now up more. We created more than 100 videos. So if you can subscribe to this channel, you have a benefit of accessing all the videos, not just one off. So if you haven't subscribed channels, it's time to do so. So don't wait until later, so you don't share the benefit of this channel. Excuse me. Sorry. Okay. Today we're going to talk about a surface area of a revolution. So surface area, how do we find a surface area if I'm giving you the function parametric? So let's have a look at the parametric function. So I'm going to use this formula here. So I'm highlighted on the right hand side, this one. So how do I calculate the using integral? So if I say I have a curve, whatever the shape is, all right? So we know the vertical is y, so which is the radius of the circle. You can see here, if I... So how do we find the surface area, not a volume? So we cut that strip, that green strip off, so to flat. So therefore, the base here is the circumference, we call C. Circumference of the circle, which is 2 pi r. R is the radius, which is r, times by the height of the, it's just like a rectangle. So length times the width. But that width is not really vertical. It's a little bit of angle in it. So therefore, I'm going to use a Pythagoras. So like we're going to enlarge that triangle. So this is the increase of dx, so which is the vertical is the dx, and this is the dy, increase of... All right, so if that's actually upside down, then the hypotenuse is dx squared plus dy squared, square root of it. So that little green strip, the area is 2 pi r times by the width, square root of dx plus dx squared plus dy squared. So the total surface area is integration from a to b. So 2 pi r, then times by that. Then with respect to, if I'm using the, we call parametric function, so with regard to dt. So I'm going to use this formula to solve this question here. So we got the x is t squared divided by 4 minus 1. So let's do dx dt, which is pretty simple. dy dt is a square root 3. Then you substitute into the formula. So that's my yt. 2 pi I've moved out. So then square root of the dx squared plus dy squared. So I'm going to move 4 out. So cancel outside with 2. So I'll make a t squared plus 12. So now I'm going to integrate this, which is, okay, I'll use the substitution method. So I'm going to move this one to inside of integration, into d, so which is integrated into t squared plus 12. So make this equal, those two yellow highlighters equal, but I need to divide it by 2. So therefore, I'm going to integrate it to 2 over 3, 3 over 2. Remember using the integration for the power integration formula from 0 to 2. substitute 2 into the equation, 0 into the equation, so therefore I got 16 I'll make it 4 to the power of 2. Square root 12, I'll make a 12 becomes square root 12 to the power of 2, so I can cancel. So you can see there's 2 cancel, 2 cancel. So there will be 4 to the power of 3, then square root 2, 2 square root 3 to the power of 3. So then I'm going to be 64, 24 square root 3. Then you take 8 out. So the final answer will be this. Using the question said we need to use, okay, we need to substitute. So we need to do one more step. We need a pi, leave it outside. So the answer should be 64 square root 3 divided by 3, then minus 24. So that's it. So that's the answer for the question 7, which is a pretty interesting question. I hope you enjoyed it. If you do, please give us thumbs up. I'll see you next time. Bye.